And we are back with question 2.2. AMTR is a rectangle. Calculate with reasons the value of x. So AMTR is 'n reghoek. Reken die waarde van x met redes. So a rectangle, of course, a lot less complicated than a kite. So nie so gecompliseerd soos 'n vlier nie. 'n Reghoek is baie eenvoudig. Natuurlik weet ons die eienskappe van 'n reghoek. As ons gou weer kyk daarna. So hier het ons 'n reghoek. And again, it's in Afrikaans, but I'll just say it in English. So number one here, we've got both pairs of opposite sides are parallel. And number two, we have got both pairs of opposite sides are also equal. And then all the angles, of course, is equal to 90 degrees. We've got, and hoeklyne, of course, in English are named diagonals. So the diagonals are equal to each other, even lank. And then also the diagonals, they bisect each other. So halveer, to cut in half. And of course, you can see all of those things on the diagram there itself. So those are the properties of the rectangle. You of course need to be familiar with these properties, and the only way you can do that is if you keep on practicing. The more you do these problems, the more you will start to remember how these properties work, and you will not confuse the properties of the different quadrilaterals. You of course will not get a page like this in your exam. You will of course need to then draw from your memory and understanding to make use of the properties or to access them. Right, so AMTR is a rectangle. We need to calculate the value of x. Now in this rectangle, depending on what's been presented to you, you will not necessarily use all of the properties of the rectangle. You need to look at what's being presented to you and then choose accordingly how you will use your properties. So we find here that within rectangle AMTR, we also have two triangles, and oftentimes, and like I've noted to you in class, just because you're working with quadrilaterals does not mean that the properties of other geometry concepts doesn't apply. In other words, you can still make use of triangles. Oftentimes, the solutions to quadrilaterals does come from your properties of triangles, and not always using the properties of the quadrilateral itself. You also need to note that a rectangle, of course, is a parallelogram, which means you're able to make use of alternate angles, corresponding angles, and so forth, in co-interior angles. So you need to take account of all of those things. Now, within this rectangle, of course, we know that this angle over here is equal to 90 degrees. Right, so you'll see that they've indicated that with angle A and angle M. You should of course know that all four of the interior angles of this rectangle is 90 degrees. So you'll also notice that 2x plus 10 degrees, which is an angle, and x plus 20 degrees, which is another angle, and the 90 degrees that I've indicated now are all the interior angles of a triangle. So in triangle MRT, right, so that's MRT, we have the following. We can say that 2x plus 10 degrees plus x plus 20 degrees plus the 90 degrees is equal to 180 degrees. And the reason for that, of course, is interior angles of a triangle. So angles of triangle, soeke van driehoek. Adding all of the like terms, we've got 2x plus x gives us 3x. And then 10 degrees plus 20 degrees plus 90 degrees gives us 120 degrees. And that is all equal to 180 degrees. So 3x is equal to 180 degrees minus 120 degrees. And that, of course, is 3x is equal to 60 degrees. And we divide both sides by 3, we get x equal to 20 degrees. Now, looking at the solution, you can obviously note that we did not even make use really of the properties of a quadrilateral. We looked at the quad that was given to us and we decided how we're going to approach this. And the only property we used of the rectangle is the fact that angle T is 90 degrees. because we know that all angles, if we go back to the properties here, we saw here that all angles, if you look at property number 3, alle hoeke of al die hoeke is like 90 grade, and we just used that one property to fill this in over here, and then from there we use the interior angles of a triangle property to solve for our unknown.